Good morning, this is Maria Insa from Glasgow Caledonian University, and my presentation, A Rapid Development of a Low-Cost Web-Based 360 Virtual Tour, is a collaboration project with my supervisor, Dr. Mark Jenkins, and Professor Gordon Morison. This project is about a 360 virtual tool pipeline that allow organizations and universities develop a virtual tour with minimal coding experience, which can compete in functionality with most sophisticated virtual tours. The use of internet has exploded with the outbreak of COVID-19, and the business and education sector have moved face-to-face events into an online format. Like many other universities in the UK, Glasgow Caledonian University have joined online platforms as well as open days to recruit future students. Although virtual open days are still a great option to allow students see what the university facilities offer, students cannot experience a walk around the university facilities. And as a result, many universities have included virtual tours in their websites to allow students experience a walk around the university. But to what extent virtual tours are an effective tool? It's been demonstrated that 360 content has great benefits to the tourism sector, for example, when exploring a future destination. Also, tourisms are including virtual tours to offer a small taste what users will visit. So similarly, university virtual tours could allow students having an experience of how the campus facilities will look, for example, the library, teaching facilities, and open spaces areas. So this can influence positively in students' applications, making campus tours one of the best recruiting tools for prospective students. But the problem is, how can we create a 360 virtual tour? Many companies are dedicating to developing virtual tours, but these ones can be very expensive. Other companies provide online courses, can be very expensive, time-consuming, and may teach you unnecessary content. 360 virtual tours can be developed in a cheaper manner and customized to clients' requirements using Google VR, Panelum, although these tools present limited functionality to compete with most sophisticated virtual tours. Other tools like GroundMe, Keprano, Matterport allow exploring the functionality of virtual tours with a temporary free package. And to actually develop and share virtual tours, you need to purchase a license. To our best knowledge, Marzipano is the only open source tool that allow the design, the development, and customization of a virtual tour, although it requires coding experience in JavaScript, HTML, and CSS. Even though Marzipano provides demos. It is true that forums like Quora and Google Forums support experienced and non-experienced users when encountering coding errors. However, these forums are used to answer specific coding errors rather than providing a full guidance on a project start to end. There already exist guidelines to develop virtual tours, but those are inaccessible by non-experts. What our work aims to do is provide a software framework and full documentation to allow any user to rapidly develop a virtual tour, which can compete with most sophisticated virtual tours created by experts. What this means is that someone with minimal coding experience can develop and customize a low-cost web-based virtual tour using our open source pipeline. This pipeline consists of using the JavaScript API called Marzipano and implementing the HTML, JavaScript, and CSS software framework published in our GitHub repository. This gives your virtual tour more functionality and interactivity than those tours developed with Marzipano tool, and also complies with the Web Content Accessibility Guidelines. Our work also includes recommendations for 360 cameras and the case study 360 virtual tour of GCU, Glasgow campus, developed following the software framework. Our software is for those organizations that are willing to purchase a 360 camera, to develop a web-based application, and utilize the Marzipano open source tool along with our software framework. Organizations that develop their virtual tours have benefits such as updating the virtual tour as many times as they want at no extra cost, and utilizing a 360 camera to live stream events. The pipeline consists on the following phases: the research, the planning, design and development, hosting, and feedback. The first phase involves in familiarizing with virtual tours and 360 cameras. There is a wide range of 360 cameras, and although there are low-priced cameras, it is important to consider the image quality, battery life and charging time, and camera extras. In this paper, we advise you on these key aspects which will allow you a better performance during the image acquisition phase. The paper also details the image acquisition planning and advises on developing a schedule and maximizing the use of the camera. The design and development phase consists of 3 parts: the image acquisition, the image editing, and the web development. The image acquisition phase consists of capturing 360 images, and the following considerations will enhance users' navigation through the virtual tour: the camera position and height, considering users' needs, and the front lens orientation, directing users' points of view. The image editing phase consists of editing the 360 images, removing the black frame at the top of the 360 images, enhancing the image color, and organizing the images in folders and renaming them sequentially, which will optimize the web development phase. Finally, the paper details the 3 parts that consist the web development phase. First of all, uploading the 360 images to Marzipano tool, which processes and adds them in a basic web application. Second, export and extract the zip folder which contains these images. And finally, implementing the code developed in JavaScript, HTML, and CSS, which is uploaded in our GitHub repository. This will add the additional features to the virtual tour, which will be shown in our case study. Once the virtual tour is finished, we advise organizations on finding the most suitable web service to host their files, setting a domain, and sharing the web link to experience the 360 virtual tour. Last but not least, we also advise organizations on running feedback sessions to ensure that the client requirements are met and ensure that the website complies the web content accessibility guidelines, making the web content accessible to a wide range of audiences, including those with disabilities. The final part of our paper presents a case study, which demonstrates the applicability of the software framework presented. The equipment utilized for this case study was a Ricoh Zeta 360 camera, an Insta360 selfie stick, and a mini tripod. The process was as follows. First of all, we agree on the list of facilities required to film, along with the set of requirements, such as adding a campus map and adding informative and video panels. Second, we planned the image acquisition schedule to inform the security team when and for how long access was required to each building, with the special circumstances of that time. In 4 days, with 6-hour shift, including 2 hours charging the camera, the team captured a total of 360 images along 140 environments distributed in 9 buildings. Then images were edited renamed and organized by campus building. After images were uploaded to Marzipan tool, the zip folder was exported and the files extracted. Then the software framework was implemented to add additional features to the functionality of the virtual tour. And finally, the web-based virtual tour was hosted and shared publicly after having a feedback session with GCU staff members. And after 4 weeks, the virtual tour of GCU was developed, a 360-degree experience that will allow future students navigating and exploring Glasgow campus facilities. The resulting virtual tour included a campus map, which provided an overview of Glasgow campus buildings, including hotspots elements which allow students to navigate to the building entrance. Video hotspots that provide multimedia content related to the environment being explored. And the accessibility drop-down menu that organizes images and rooms by building and complies with the Web Content Accessibility Guidelines. In conclusion, this case study, along with the positive feedback from cross-departmental staff members, demonstrates the effectiveness and the applicability of the proposed pipeline, which will allow universities and other organizations to stay competitive in the evolving landscape of 360 virtual tour technology, and furthermore, helping students to gain a better perspective of campus facilities in these times where social distancing measures have made open days virtual events. Thank you very much for having me in this conference, and I look forward answering any questions.